Hello and welcome to Bowler CBT Labs. My name is Matt Bowler, and in this video we'll be taking a look at implementing an SSL VPN using the ASDM on the Cisco ASA platform. We'll be using both the clientless and the client-based, the AnyConnect more specifically VPN. We'll be launching the AnyConnect client and demonstrating connectivity. And then we'll also look at some of the features that are available in the clientless VPN, which is accessible via a web portal. That web portal is customizable and has some pretty cool features, so we'll look into that a little bit as well once we get to that point. But first, we will start out with the ASA. It has a base configuration that I've installed that has interfaces configured. You have the ETH0 or Gig0 interface, which is technically going to be considered the outside interface of the ASA, and ETH1 will be our inside interface. On the router, we have Fast Ethernet 1.0, which is considered the outside, and Fast Ethernet 0.0, which is considered the inside, and that connects to a loopback, which is local to my laptop. We'll be using my laptop as both the ASDM management gateway, so we'll use my laptop to actually connect to the ASA through the ASDM and perform the configurations. And we'll also be using my laptop as the client for the VPN connection over to the web server itself. Our end goal here is to have the laptop establish a tunnel to the ASA using the AnyConnect VPN, which we will install via the web GUI. It will be assigned an IP address on this local /24 LAN on the inside interface of the ASA, and it will have connectivity to that /24 itself. We could kick off ping here to show that it's not working. Well, first of all, it's not going to work because I haven't configured the server yet. So I'll go ahead and do that real quick. It's ETH0 on the server. We'll assign it the IP address. It should be able to ping its next hop. Yep, so the ASA is responding to ping. However, you can see it is not responding to the laptop. And also notice I did not put a route on here. So there's no default route or anything. You have just the two routes, the local host and the route for the segment, which is directly attached to ETH0. In order to launch the ASDM, there are a few prerequisites. We need to run the HTTP server. I have it enabled over port 4443, which is a non-standard. The command HTTP server enable will allow us to specify a custom port, or you can just hit enter and it'll use the default port of 443, which you can see here. The next thing we need to do is enable management, and that is done via this line right here. HTTP, saying that it can be managed via this, it's actually /30 network, where my laptop loopback interface resides, and that would be expected to arrive on the outside interface. So you can see the HTTP. This particular section right here, this is the IP address of the host or network authorized to access the HTTP server. So if I put in some arbitrary IP address, you can see the next option is the net mask. So if I wanted to host only that host to be able to manage it, we would go through and specify the IP, the mask, and the interface on which to accept the connections, or where we should be expecting them. So those commands are already present. There's also a requirement to have a username configured. In this case, it is admin. We'll be using that to log in to the web portal as well, where we will begin and initiate the VPN client download and then look at some of the features that are part of the clientless VPN. I will also mention that we need to copy over the ASDM, which I have not done yet, and that takes a few minutes, so I will pause the video, copy those files, the ASDM over, and a couple other files which we will reference later on. Let me pause the video, copy those over so you don't have to wait through that transfer, and I'll be right back. Alright, we are back. I copied 3 files over to the ASA itself from my laptop, one of which was the ASDM file, which is required in order to launch the ASDM. If I do a show run on the ASA, you can see once you copy the file over, you need to specify where the image is located using the ASDM image and location command. Once I actually go to launch the ASDM, you can see that we've made contact with the ASA, and it's going to load the software. If you don't have the image available, it will download it for you, and you can also go to the IP itself. So I could launch the web portal for the device, and you'll see that I've reached the ASDM portal. I can install it or run a startup wizard. So I already had it installed, and that's where it's talking about the local installation, the cached copy that it was able to locate. We've got the main landing page here, the device dashboard. We can see the host name, ASA1, the version that we're running, 842, ASDM version. Firewall's running in routed mode. It's a simulated ASA 5520. It has 1 gig of memory allocated to it. See, our interface status here looks okay. Obviously, we knew that since we were able to ping from the web server earlier to its peer over on the ASA side. And we were able to reach the outside interface from the laptop. So we know that the connectivity is working to the inside and outside interfaces of the ASA. In order to begin the VPN configuration, we'll need to jump over to the Configuration tab and down here to the Remote Access VPN. We'll be configuring the AnyConnect client first. In order to run the AnyConnect client, we need to have an image available that the clients can use to download and install in order to run the application, since this is a client-based VPN. So under the AnyConnect client software item, we will select Add, and you can either upload a file from your computer or you can choose to browse the flash. I copied it over earlier, so we'll browse the flash and we can see This, I tried a couple different versions, and this is the version of the AnyConnect that worked for me. I was able to download this from cisco.com using my active account. I don't know if you can get a copy of this elsewhere, but it's available to registered members who have service contracts through Cisco. So make a note of this if you have the ability to go download it and you were maybe using a different version than this and you're running into problems. I was running into issues where it wasn't able to modify the local routing table on my laptop. It was something to do with, I want to say it's AnyConnect version 3, one of the newer releases. It wasn't working as expected. So I downgraded, got 256. And this version has worked out well, and we'll demonstrate how it works in just a few moments here. This is actually, it's a pretty straightforward setup. There's a lot of flexibility, but in this instance where we just want to do kind of a bare bones setup and demonstrate the connectivity, it's pretty straightforward if you understand how Cisco is going to have you bouncing around all over the place. But it does work, and it serves its purpose. And there's a lot of features that you can utilize here. So we'll go ahead and select that image as our candidate and apply. It's going into the WebVPN subset of configuration here, and it's going to specify the AnyConnect image to the file located on disk 0. So we'll send that command. They recommend that you restart the ASDM in order to refresh any sort of features related to the client profile plugin. We're not doing anything with the client profile plugin. This is purely the software. If we do run into issues, we can restart the ASDM, but I haven't run into any specifically. So maybe we'll hit some for the first time, but I hope not. Next thing we'll need to do is enable the actual Cisco AnyConnect VPN service. We can do that by selecting AnyConnect Client Connection Profiles, select Enable, and we will enable SSL access on the outside interface. When we reference the diagram, we can see that the laptop will be coming across and terminating here on the outside interface of the ASA. So that's where we want that to terminate. Next, we will need to generate or select a device certificate. You can see that there's none currently available, so we'll need to go in and add one. I'm going to leave a lot of this as default. I'm going to add a new identity certificate. This will be self-signed. There's no key pair, so we'll go ahead and generate a new key pair, and we'll call this the SSL VPN key. Generate that. See the command that it's going to send in order to generate that. It takes just a few moments depending on the size. It's only a 1024-bit key, so it doesn't take too long. We will leave the attributes bare bones, so we'll just have the common name, the host name itself. There's some more advanced options where you can specify the certificate parameters here. We'll just go ahead and leave those. Add the certificate, and we can see the commands, the string of commands that it's going to send down in order to perform the tasks that we just asked it to do. So it's creating a trust point, specifying the key pair to use, didn't specify an FQDM. You can see where it's specifying the subject name for the common name of the host name itself, self-enrollment. Go ahead and send that. So we've successfully enrolled. We can see that we have an identity certificate here. It's registered, and we'll hit OK. we'll use that certificate. And then we'll bounce down here to the connection profiles themselves. We will not be using IPsec. We'll be using SSL. So we'll click SSL. We'll jump down here to the default WebVPN group, and we will edit that. I mentioned earlier that we want to create a pool of IP addresses that sit on the /24 inside LAN right here. I'm going to take just a small chunk out of that /24, and we will call this the client. We'll do it the SSL VPN pool. We'll call it that. And then the start will be 10.1.1.20, and we'll go up to 29. So 10 IPs available. Don't necessarily need to specify the subnet mask. Go ahead and hit OK. Assign. Oh, we will. Let's see here. Edit. We'll go ahead and specify it just for the sake of specifying it's on that /24. So we'll hit OK. We can see the authentication method here. We could use certificate-based authentication. We could use AAA, or we could use both. We'll use AAA, but we won't be using any sort of external servers. We'll just use the local user database. And that's where, if you recall, I mentioned earlier, we'll be using the admin account to authenticate through the web interface. I don't have any sort of DNS or any other servers to configure here on this particular lab, and you'll see that it's going to say it's recommended that you configure a DNS parameter, which will be sent out to the client so that they can resolve host names once they connect to the VPN. It doesn't apply here, so we're not too worried about that. That's the only configuration that we need to do within this portion, but you can see there are many other options available, and this is what I was just talking about. So DNS servers is required for the remote users to navigate using FQDNs, the fully qualified domain names. Would you like to set it up? No, because I don't have a DNS server that I can use in this particular case. So you can have interface specific address pools for both IP4 and IP version 6. The different authentication methods, and you can do that based on interface, secondary authentication methods, authorization, accounting, and group alias and group URL settings. All we need though, we really need here is we're going to use local authentication, and we need a pool out of which addresses can be assigned to the clients. So we'll confirm that. No, I don't want DNS servers. I'll apply. We can see that we're creating the local pool. It's saying the SSL trust point be set up for the outside. So we'll apply that to the outside for connections coming inbound from external sources. You can see some of these, the group policy attributes that were changed when we went to apply that, because we set we don't want to be using IPsec, but I'll show you where this configuration resides in the next section. And you can see that under the tunnel group attributes for the default VPN group, we're specifying that the address pool should reference the one that we created earlier. We send those commands and then jump down to group policy. So here's our default group policy. Under here, we can specify the tunneling protocols that will be active. You can see the clientless SSL VPN, the client-based or AnyConnect SSL VPN, IPsec, and the layer 2 L2TP IPsec VPN. All of those are enabled. We don't want to use L2TP IPsec or IPsec version 1. So we can go ahead and deselect those. Hit OK and apply. And you can see it's going back in and it's taking the same command that it applied earlier, but it's stripping off those two IPsec oriented parameters. So we're just using SSL clientless and SSL client-based. So a little bit of cleanup there, cleaning up some unnecessary services. Next, we can jump down to the clientless SSL configuration. You can see that it's inherited from the client-based connection up here, where we specified use the outside interfaces for SSL access. It's taken that as well, and you can see the same. It's going to take us to the same portion of getting the device certificate, specifying which one that we should use, allowing us to create one if need be, and so forth. We can also specify if we'd like it to terminate on a different TCP port for HTTPS. We'll just use the default in this case. There's also an option here to enable VPN sessions and allow them to bypass ACLs. You can apply ACLs under the group policy or using authorization access lists, but we will just bypass those in this case and leave it wide open. Under the portal itself, when we arrive at the portal, we will see that there are several applications available to us, many of which are built in, some of which require plugins. To show you where those applications are configured and which ones are presented to the users, you can jump down to the portal and customization item. This is under the clientless SSL VPN access. We'll open up the default customization template here. And under the portal page, you can see the applications that are available. There's the home, web applications, the ability to browse networks, the AnyConnect client. There are specific application access methods that you can specify, certain plugins that you can get. There's an SSH and Telnet plugin. We will install an SSH plugin and show that, although it will not function with the Java that's running on my computer. I think it might be an old plugin that has some compatibility issues, but we'll go through the process to show how you can enable a plugin and restrict or expand the features that are available to people as they authenticate to that the web GUI or the portal landing page. To do a little bit of customization here, we can see that when we're presented with the login page, there are many fields that are going to correlate to the HTML content. So on the title pane, let me just see, save this and bring up the portal itself. See, it's timing out. Let's view the logs and see if we can figure out why. Ah, it's being denied naturally. All right, let's jump over to the firewall. Filter out only IPv4. Okay, here's the issue right here. The outside access list here is only set to allow connections from the host IP to the server IP. So if we were to change this to we'll just say any. And apply. And it's still denying it. You can see our pings are still failing because the routing isn't in place. But this should work. I don't know why this is being denied. Let's try and bounce this. See if maybe that fixes it. See if we can still ping that. I know we should be able to, yes. But it still denies. I apologize for the inconvenience here, but sometimes you have to do a little bit of troubleshooting. It always comes at the least opportune moment. Alright, let's kick that off again and see what's happening. I don't understand why this is not working. Denied by ACL. Let's try removing the ACL. Okay, that should definitely deny it. ACLs. And ACL. Outside access in. And we'll just say any apply. Oh, be asked to refresh. Should be asked to refresh the ASDM after a change via the CLI, since it won't be in sync. So we should see that change reflected. There we go. Why? I don't understand. This just makes no sense. I'm wondering if maybe there's an issue with GNS3 in this case. I'm going to stop and pick back up where we left off. I'll be back in just. Sorry about that. I restarted the ASA and the ASDM, and once it reloaded, I noticed that everything looked okay except the SSL access boxes were unchecked for the outside interface. And when I checked them and hit apply, I can see where it's wanting to go back into the WebVPN configuration portion and enable the service on the outside. So let's try that and see if we run into the same issue. We want 2.2. There we go. Okay, now we're getting a page that we expect. Go ahead and add the exception for the ASA. All right, here we go. This is exactly what we were looking for. This is the portal login prompt that I was referencing earlier, where we will use our admin login. And you can see the bar over here on the left, the navigation bar, is going to give you a rundown of the applications that are available through the portal. If you recall, under the Clientless VPN Configuration section and customization, we could go into the customization template here and look at the applications available. So if I wanted to disallow everything except for SSH and Telnet, the AnyConnect client and home, go ahead and deselect everything, hit OK, apply, send. And when I reload the page, we can see that we're down to home and AnyConnect. Now, if you recall, I had enabled the SSH or Telnet plugin if available. There's not one currently installed. I went to, I believe I got it from cisco.com and downloaded an SSH plugin. It's very old. It references Java 1.4, so it's pretty old and it doesn't work. But I just want to show how you could go in and use a plugin. So we're going to import a new client server plugin. We can see the different types of protocols that are available to us. There's RDP, some well-known applications, things that are used to manage servers. So we would like to use SSH or Telnet. In this case, it's SSH. And we can upload using a local file. We can reference the flash that's running on the device, or we could upload it or download from a remote server. The file exists on the flash, so we can browse. This is the plugin right here, SSH plugin 111.006.jar. It's a Java file. It's a Java plugin. We'll hit OK, import it. We can see that it was imported successfully. There's nothing that we need to do to apply that. It will automatically import it in. I believe it's using some sort of activate command to perform the actual the plugin activation. So then when I refresh, we will see that we now have the option for the SSH Telnet client. And if I wanted to SSH to something, I could put in the IP. Since we don't have DNS set up to use FQDNs, and then it would launch another window, like a pop-up or another tab, which will act as an embedded SSH client. In this particular case, we would like to do the AnyConnect. So we'll go ahead and kick off our ping again to the destination server. Before we do that though, let me just show you a couple of the customization features here. You can see the title SSL VPN, and at the home page, it's not going back there. Just go ahead and log out. Okay, go back to the login screen. So if we want to customize, we can go back into the customization template, select edit. A login page will say this is the Bowler CBT Labs SSL VPN. So the text in our title pane will say Bowler CBT Labs SSL VPN service. You can specify custom styles, a logo, different styles for the font and the presentation of the page. We can have different languages available so that you can select based on your region or preference. The login form, we can customize each one of these fields. So we could say this is the Bowler CBT Labs SSL VPN login. Please enter your username and password. Authorized users only. That'll hold water in court in case someone tries to break in. I personally feel like uppercase means someone is yelling at me, so make it a little bit more formal. And there are various other fields that we could fill in here. So the portal page, we'll replace this with the Bowler CBT Labs SSL VPN service. Toolbar, you can change some of these custom prompts. I'll just leave that as address. We talked about the different applications. There are custom pages and panes that you can add. We won't deal with any of those customizations. And you can see down here on the logout page, we saw this already, where it's giving you a little bit of information. Clear your cache, delete any downloaded files, and make sure you close the browser window. So we hit OK. You can also preview those changes. We'll just go ahead and hit OK and apply. And then when I reload the page and log in again, we should see those changes reflected. You can see we had the Bowler CBT Labs SSL VPN service. And also, when we log out, we see it reflected there as well, and right here. And when we log in, we change the uppercase to lowercase. Simple, I know, but it's the little things sometimes. Now, in order to initiate the AnyConnect VPN session, we will select AnyConnect, start AnyConnect. It's going to do a little bit of an automated process here, asking me if I would like to accept a certificate. Yes. We'll see the VPN is going to attempt to establish the connection. And it shows that it's connected, and voila. We are now able to ping the destination server, even though the destination server has no route. If I jump down to the ASDM and do a little bit of verification here, we can see, actually let's look at the login and see if there's anything in the log buffer. We should be able to see where this is what I'm looking for. The client was assigned an IP address from the pool, so it grabbed that first IP. Says that there's no IPv6 IP available. We're not concerned about that. So you can see where address, user admin originating from this address is using the AnyConnect, and they were assigned an IP from the pool using this tunnel group, the default WebVPN group, pulled it from the local pool, 10.1.1.20. I can jump over to VPN, the VPN section, and look at the client-based VPN. You can see right here, there's one client connected. And if I want to filter by AnyConnect client VPNs, we can see my specific connection, username admin. You can see my public IP, which is the 172.16.1.2, and the address that was assigned from the local pool, which is 10.1.1.20. The duration, the time, if there's any sort of inactivity, the amount of data that was transferred, protocol and encryption method as well. So we know that it's working. Now I'm going to do a little bit of an experiment and set up split tunneling. The LAN that I want to advertise and enable for split tunneling, I'll actually do two. I'm going to have it tunnel traffic for the 10.1.1.0/24, and I'm going to create another make-believe network, the 10.1.2.0. And our connectivity won't work, but I just want to show how you can do this, how the functionality exists, and how we can see that the route has been installed in the routing table. If I want to look at the routing table on my laptop, I can do route print, and then I'm going to find 10.1.1. Oops. And you can see that I have a route that was installed for the 10.1.1.0/24, and it's referencing an interface that is configured locally. So this is the VPN adapter itself, and you can see it's referencing the IP address it was given to me from the ASA itself from that local pool. Now, if all goes well and we set up the split tunneling, we should see an additional route 10.1.20/24 that's pointing to the interface configured with the IP from the pool. I'll go back to the ASDM and go to group policies. We will edit the default group policy. Go down to the advanced section and configure split tunneling. Right now it's set up to tunnel all networks. What we would like to do is have it only tunnel networks from the list below. You also have the option to tunnel everything minus the exclusions. And we'll do that by configuring an ACL essentially to match certain networks. So we'll tunnel the network list below. See there's no lists that currently exist. We'll go ahead and manage it. We'll create a standard ACL, and this will be called our tunneled networks. Add an entry to this. So we will allow 10.1.1.0/24, and we will add 10.1.2.0/24. So we'll permit both of those. We'll say when the client connects, modify their routing table to only tunnel the networks in our tunneled networks group. You can see it's creating the access list, the standard access list. And it's going to alter the default group policy. So the split tunnel policy is it's specific, and then it's going to use the networks that are specified within the standard ACL that we created. So you can see that the update was not pushed automatically. What I'm going to do is disconnect, or I could actually log this session out administratively. And you can see right here that the VPN client has reported the administrator reset my connection. Okay, go ahead and reconnect. Accept the certificate. Put in our password. going to check for updates. Establishing the connection. Let's try another ping to see if it's established. It is. And then we'll take a look at the routing table here. So there are two main differences. If you look right up here before, the default route was pointing to the IP of the pool, the IP address that was given to the client through the VPN itself. So we had the default route that was pointed to 10.1.1.20, that on-link connection used for the VPN tunnel back to the ASA. However, when we did the similar search, we actually included more results. Right here, we were just looking for 10.1.1 in the list of routes, but here we're looking for 10.1. And we can see when we did that before, the default route was there right here, and the route for that LAN was there. However, there is no route for the 10.2.0. Now we can see the default route is gone, and it's been not necessarily replaced with, but we see again the route for the local network 10.1.1.0/24, and the tunneled network, the additional tunnel network that we had specified using that ACL, has also been sent, and the routing table has been updated to reflect that. So any traffic destined for those two networks that we specified within the ACL for tunnels to be networked are present within the routing table local to the client itself. So there's a little bit of a quick example of how you could set up split tunneling. It's quite useful. I think it's fun to tinker around with things like that and see them work, see them not work, like we experienced earlier, which now that I think back, they said it's good to restart the ASDM after making any sort of AnyConnect profile changes, like we did when we uploaded the AnyConnect image and configured it back here under the client software. It had said you may want to restart, so we probably should have taken the advice and restarted. Learned from my mistakes. That's why we're doing this in the lab. I do apologize for the momentary pause that we had to take while we figured that out. We stumbled across an inconsistency. I don't know if it's necessarily considered a bug, but we saw it and I was able to track it down pretty quickly and then show you exactly what I did to fix it. So in this particular lab, just as a review, we looked at the ASA, we brought up clientless and client-based AnyConnect VPN. We established a tunnel between my local machine and the ASA to bring up the AnyConnect connection and then ping all the way through to the web server. We also access the device via the ASDM and perform the configuration entirely using the GUI. As you can see, there are a lot of features available. It's a very feature-rich system, and I, as always, recommend you taking the time out to go through the lab yourself, customize it how you see fit, maybe dive into a little bit more of the features that are available, and I hope you have fun. Thanks. I hope this has been useful and you're able to take away some information.